Hello, my name is Andrei Kulikov, and in this video I'd like to show you how to increase the chance in winning in the lottery. It's only a test and I did not won in it yet, but let's try. So here is one example of a lottery where we have to choose five numbers from 36 of them, and if you choose all of them, you will win. So I'll use two methods for that. First is machine learning method, and second is a statistical method. So machine learning method does not work, but it will be interesting to explore. So I have a data set of the lotteries, of the draws of the lottery. It looks like this. So the number of the draw, it's about 100 years of the history of this lottery, and so and five numbers. So I'll use this data set in my experiment. So first is machine learning test. I'll use a sklearn model for that, and I'll load the dataset. The delimiter is a comma. It is very important. Let's look in WordPad. Yes, it's comma. So what I see here, the number and the number of the draw and the numbers. So describe the data set. So here I see that the mean of the draws is 18. Minimum is 1 and maximum is 36. And we shall see later that the result of SK learning learning process will be 18 also. And I also checked it in AWS SageMaker. It also give me 18. Uh, so I'll make the multiple training model where the target is my columns with my numbers, and I'll use three models in sklearn model: linear regression, random forest regressor, and neighbors regressor. So some data sets transformation for training and testing. So here is my data set of the draws, the number of a draw, and I'll do the following. I'll put in my model the next number of the draw, and in hope that it will give me the result. The number will be 53237. Naive. Okay. Here is fitting of the model 0. It is first of this list. So let's go. Some I'll use pandas data frame for transforming of this number. Don't ask me why I use it, but it works with I found it by some experience. So don't ask me. So it gave me the results. It differs, but it's only 18. If I use a model of random forest regressor, I'll get other numbers. But if I put this value to 10,000, it will be closer to 18. I hope. When I did it, the process interrupted and it did not fulfilled. So and k number a regressor will give me something like 18. So machine learning doesn't work, but we have statistics. So the second way to experiment is to use the principle of normal distribution. So I'll use the counter method to see how many times the number was chosen. So and the minimum chosen numbers with the highest probability will be chosen later. Concerning the principle of normal distribution that says us that all the numbers will be used, will be chosen in equal chance. So I load the dataset. I use here semicolon. Let's check. It's for experiment. I put the headers on it. So and here is the method of the counting, minimum and maximum, and some plot. So let's start. What I see here, it gives me this counting, and it gives me a minimum of the first item is 17. Here it is. Second is 28, 23, 1, and 33. So I suppose that next time these numbers will be chosen with the higher probability. Of course, they will be cho guaranteed chosen guaranteed, but the chance will be higher. And also, this can be checked in the graphs where we see that minimum numbers are here. For example, where I had one in the fourth column. Yes, so here it is. So that is all. Maybe it will help. Maybe there are some combinations not only with the minimum but next to the minimum, but it's fortune, but the chance becomes higher than it was. So thank you very much for watching this video. See you later. Bye.